All right, so now we're live.
Well, there was nothing else. It was just 4 things of whipped cream.
Trevor's like, whipped cream, whipped cream.
So in linear substitution, we have linear equations, a system of linear equations, okay? And we're going to move some variables around and substitute some things for other things. What I mean by that, concretely, is you might see something like y equals 3x plus 2, and you might get something like y equals x minus 1. Whoops, minus 1.
Can I do it?
Because there are 2 equations here, we can work this around, substitute some values, and get things to work out.
You have to plug in one of the y's to the other y.
You do. So we already have y on its own, which is nice. So let's plug in this y up here. I'll do that in blue. So now instead of y equals, right, we're going to do x minus 1. I'm having trouble with negatives today. Equals what we had before, which was 3x plus 2. So all I did was take this y and what it equals and substitute it to here.
Careful of the cord.
I got it. It's all right.
Sorry.
It's okay.
Sorry.
Miss Sexualty.
Give me a piece.
It's okay. Share it. Share it.
What kind
What
is it?
kind?
No.
Oh, no, I didn't grab it.
Nuts. Okay.
Wait,
You
is
bring
it
the one over to the other side.
Add 1 to both sides. You add 1, then minus 3. You add 1 to both sides.
This is why we lock the door, so weird people don't come in.
True. Trevor, and throw chocolate at us. Oh my god.
All right.
You're telling me if someone threw chocolate at you, you wouldn't sound like that?
So I'd like to get out of here as early as possible, and in order to do that, we need to
Until
do the
next
thing.
5:30.
Yeah,
Right.
we're gonna be here till 5:30 because Natalia is my ride.
Okay, so if I only get through 2 things, I only get through 2 things. Not my problem.
Okay.
Okay.
Okay?
Stop. Yeah.
So here we are. We substituted this for that. So it's x minus 1 equals x, 3x plus 2 now. We need to get x on its own. An easy way is to put x over here, subtract 1.
Add 1.
Minus 3.
I'm sorry, add 1 from both sides. 3x
Plus 3.
plus 3 now.
Divide by 3 on both sides.
No, we gotta get x over here.
So wrong. That's so
So then
wrong.
we
Subtract
3.
3x, and we get negative 2x equals 3.
And then divide by
Divide by negative 2, and we're left with x equals negative 3 halves. And proper fractions are your friends, guys.
Then
Don't
you
think
pull down
1.5. It's awful. Okay?
X minus 1.
Now we need to plug that back in up here. Either one will work.
Y.
Let's plug it in here.
Yeah, that one's easier.
Y equals negative 3 halves, right? That's what we plugged in for x. We're going to find
I
y
got this, I
now.
got this, I got this.
Minus 1.
Negative 1.
We need to have common denoms. So the way to do that is to multiply this by 2 and this by 2. Same thing. You see how I didn't change anything? It's just different perspective.
It's
Negative 3 minus 2 is negative 5.
negative 2 and 1/2.
And then the 2's come along for the right.
Yeah.
Here's our y value, here's our x value. We need to represent this as a coordinate because what this means is where these 2 lines, equations of a line, intersect. So the coordinate that they intersect at is negative 3, 2,
Are we gonna have weird points like that?
negative 5 halves.
Yeah, we're gonna have like weird numbers like that on
He
the
said
bottom.
no.
That is not weird. That is a normal number.
Is
Like
it
it's-
gonna be real numbers or decimals and?
There's not going to be decimals. Use improper fractions,
Will that
right?
be
Well, obviously, but like.
Like,
Yeah.
like
Whoa!
graph it? Will that be in the final?
Graph it?
Yeah.
Yes, but it'll graph
it
nicely.
like-
No.
Are you giving us a
And
graph?
any graph I give you, you won't actually graph it because it's a Scantron. You'll select which graph is actually the picture of the thing you're trying to do.
Oh, that makes my life-
I hate
Thank
you.
You're welcome. You're welcome.
Thank you.
It'll be okay. It'll be okay.
I don't feel good.
So this is our answer right here. The coordinate at which these 2 lines intersect is here.
Gotcha.
Cool.
I got that. Can we do a word problem?
Sometimes, we're not there yet. Sometimes we get 1 solution, sometimes we get 0 solutions. It depends on what's going on. Sometimes we get infinitely many solutions. I'm going to show you one where you get infinitely many solutions. So erasing this.
Can we do them on the board? For practice?
Not this second. This isn't just for you guys, it's for the people at home too. Okay?
Oh, sorry.
So I got to do the thing and then we can do examples. Alright?
Oh, yeah.
So let's do problems on the board.
Yeah.
Let's give this one. This one's going to have multiple solutions.
We did. Oh, sorry.
This is going to have infinitely many solutions. How do I know that? Because the slopes are the same. The slopes are different now, but we need to get this on its own. We need to have y and y on both sides. We need to get it into slope-intercept form. And so we're going to take this guy, and we're going to divide both sides by 2. And what we get from there is we get y equals 4x divided by 2 is 2 plus 1 with our x. They're the same thing. Because they are the exact same line, they're going to have infinitely many solutions. If I were to graph the exact same line, we'll color this one red. Actually, we'll do this one black, because it is black currently. And this will be my red one. So let's graph the black one, which is 2x plus 1. So our intercept is 1 right here. And we go up 2 over 1. We can do the opposite of that, going down 2 over 1 in the negative direction. So we have this line. When we graph this guy over here, we're going to do the exact same thing. Y-intercept is 1. Oh, it's this guy. Up 2 over 1. Look, it's the exact same line. And because it's the exact same line, these lines intersect at every point ever imagined. So it has infinitely many solutions. That's the sign for infinity. Infinitely many solutions. Solid. Because they're the same line. Again, you have to have the same slope and the same y-intercept for them to be the same line. If they have different y-intercepts, like this guy up here had this, plus 2, then when we graph it, we're going to get this.
Parallel. Sorry.
Plus 2, and then up 2 over 1, down 2 over 1.
Wait.
Oh, sorry, that's not what I meant.
I have a question.
My
Here.
face really hurts from this people.
They're parallel. They'll never, ever intersect. So there are now no solutions to this. So the only thing keeping you from having infinitely many solutions and no solutions is your y-intercept. If the y-intercepts are different and the slope is the same, then they're going to be parallel. No solutions will never connect, so they have no intersection point. They have no coordinate that aligns them both, where they both intersect.
So that's when the slopes are the same.
But the y-intercept is different. If both are the same, then we have the same line, right? 2x plus 2 and 2x plus 2.
That's infinite.
Infinite, because they're the same thing, right?
Yes, sir.
They are 1. Any other line that has a different slope or a different y-intercept or whatever, right, will have just one point where they connect.
Okay.
Just one point. So your options are 1, none, and infinitely many. Cool. So let's do some examples on the board and bring some people up here. Who wants to be on camera?
Me!
I figured.
Alyssa!
I'm going to pick the least annoying people to come up here and do stuff, so now you know what I really think of you. All right, so y equals 3x plus 1, and 3y equals 2x minus 4. I want you to find the coordinate, so the coordinate of where these two lines intersect, and the way we're going to do it is linear substitution. We're going to get y or x on its own and substitute. If you're going to do it, you need to do it in blue. Who's going to do it? Lindsay.
Ah, yes!
He doesn't want to put cream. You can have it.
No promises. Okay. Don't stand right in the middle. They can't see. Stand to the side. They can't see the board. There you go.
Left-handed.
Yeah.
Excellent. So you divided everything by 3 on both sides. That seems fair.
Oh my lord, this looks hard. Okay. 2/3 x minus 4.
I don't need your attitude.
Plus 4/3.
We're in high school. We can do fractions. It's okay.
I can't do
I never really learned that.
I can teach you if you need me to
Okay,
teach you about
so
Can you?
I'm gonna go to
what's 2/3 minus 3?
That way around. I'm sorry. No, keep it in fraction form. No decimals.
5/3?
Negative
Yeah.
2 1/3.
At least I think. I can't really see it from
Yeah, I think it is 5/3.
1 or 1/3?
1 4/3.
No, 4/3 plus 1.
4/3 plus 1 is the same thing as 3 over 3, right? Same thing as 1. So it's 7/3.
Oh.
I can teach you that in a second. If fractions are our
That's
issue, I can teach
7/3.
fractions.
That's 7/3.
1 4/3 is the same thing as 7/3.
No.
1 plus 4 over 3, 7 over 3.
Yep. 7 over 3.
Because like say, okay.
1 is the same thing as 3 over 3.
Like you're adding
3 over
1
3
to
plus
the
4 over 3
fraction.
is 7 over 3.
So like 2 plus 4/3 would be 2 and 4/3.
I didn't hear what you're saying. I wasn't trying to hear it.
I got 0. Is that right?
0 for x? Potentially, yeah.
Let's see.
Okay.
Now plug it in.
I'm just kidding. Okay. Okay, now I plugged.
Somebody downvotes on this video. All right, so it's 0 for x. What's your y value?
I don't know yet. So I gotta plug that into. That.
Oh, it's 1.
It's 1. Okay,
Yay.
can I graph it?
Check it.
Check it.
Plug in 1 and 0 into your other equation and see if you get the same answer as the top one.
1 equals.
3 times 1 equals 2 times 0 minus 4.
Huh.
Oh,
Okay.
that's wrong. That is wrong. Lindsay, you
Lindsay,
did wrong
it's
math.
Sorry.
You did wrong.
Don't waste my markers, please.
I guess I'm wrong.
You did it wrong.
You cut that out of the video?
Are you cutting it out?
No. I got it wrong. What did I do wrong?